All right, so today we're looking at binomial expansion. So in our formula sheet, right, this is what we'll see in our formula sheet. And for me, I'll just use exclusively these for when I'm headed for when I'm doing the questions. So this will be the general formula, right? Where A is the first number on the left and B is the second number on the right. N would be the power, right? And the bottom number here matches the number R. So what is R? So the first term here we notice happens when there's nothing here. It actually corresponds to N choose 0. So basically for the first term, R would equal to 0, right? So in our expansion, we're going to focus on the general term. We'll be focusing on the general term, which looks like this. This would be our general term right here. Right? So based on the general term, in our mind, always remember that R starts from 0 for the first term. Right? And next I'm going to share a little bit on what it would look like if we're referring to the third term in an expansion with power 8. So for third term with expansion power 8, it looked like this. So our bracket would have been 8, choose 2. So where n is 8, third term happens when r is 2. So remember that r is always 1 less than the number of the term, right? So third term means that r is 2. So how do we process this? Now, many of us might get confused if we see this part and it looks so off-putting, right? So what I do is to keep it really, really simple. When I see 2, what I do is that I will multiply the numerator from 8, which is the power, and multiply by the next number down. So I'm multiplying 2 numbers. Because the r is 2, then I'll take as 8 times 7, which is the next number down, right? In our denominator, we start the other way. We'll start the regular way, ascending order. In the denominator, we go from 1 and multiply upwards on. So the denominator would have been 1 multiplied by 2. So that's our shortcut of doing it. In our calculator, you can actually use something like this. You can key you can find in your calculator the number 8, and then you're going to choose this button called the NCR button. The NCR button. So choose N, type 8, then find the NCR button. And because we're looking for the third term, we key in the button 2. Right? So that's what so that will give you the same calculation as what you see here with the 8 times 7 out of 1 times 2. So next, we're going to give an example. So if we're expanding the first 4 terms of this expansion, which is 2 plus 3x and everything to the power 8, so this is how it looks like. So it equals to, notice that in the general formula, I just modified it a little bit, right? Because I want us to get a visual very clearly. So because the n in this case, because the power is 8, so the n, this top number always goes to 8, right? And the bottom number, right, it always starts from 0, right? And then the format keeps the same. So next number 2 matches with here. So let's show clearly where the 2 goes. This 2 came from here, right? The 2 came from here, right? And notice the power, the pattern, I've already started the pattern. So I start from 8 minus 0, right? Which is basically the n minus r. There's no contradiction there, right? And then followed by multiplied. This is multiplied. So this expansion multiplied by the next number, which is 3x. Next number 3x. Oops. Do that. Right, next number is 3x here. Let's try it. Doesn't want to work. Oh, right here. Yeah, it was a little bit laggy there. Let me move it. Choose this line. Okay, let me undo that. Right. So let's draw the line. So the 3x matches here. This was the second number, 3x, right? So 3x power starts from 0. 3x power starts from 0. Right, and then we go to the next term, which was again n maintained as 8. Now r increases to 1. 2 still the same first number here. 2 still the same first number here, right? But the power of 2 has now decreased by 1, right? And then for b, multiplied by b, which is 3x, and then power goes to 1. And then the next term, 8, choose 2, right? Again, 2 came from the left term. Now power has decreased by 2. b, 3x, power increased to 2, right? And then here 8, choose 3, right? Again, power decreased by 3. And then for b, power increased by 3. So we key this in carefully and patiently. We go on to the next part. Right, so I just broken down really cool because we've multiplied 3 different numbers. So I'm showing what happens to each of these numbers, right? So a choose 0 goes to 1, and you can key 8 and CR0 to verify for yourself, right? And then 2, I just kept the power here. 2 to the power 8, just simplifying the power. Anything power 0 here is just 1, right? And then I do the same for the next term, the x term. A choose 1 was 8, to say 2 power 7, 3x here, right? And again, a choose 2, and I key this in, it should give me 28. Right, and then 2 power 6, and then here I expand whatever is inside here. So this is the other potential thing that we need to take note of. So importantly here. Yeah. So what we need to do here, right? So for 3x, notice what happened to 3x. When we expand the 3x square, right, we have to square both the number and the letter. So 3 squared goes to 9. So we have to do that, right? And then next time we goes 8 choose 3, 8 choose 3. So that gives me 56, key it in. Again, power of 2 goes to 5. Again, same idea here. The 3x, we have to multiply the 3. We have to cube both the 3 and the x cubed. So that gives me 27, right? So if I key this in carefully and calculate it carefully, it should end up like looking something like this. And yeah, strictly speaking, we need to do an additional thing here. When we do our expansion, always, when they say up to the 3 terms, we do not stop at the 4th term. When they say expand up to 4 terms, we do not stop at the 4th term. We actually need to key it in and multiply and include the plus sign and the 3 dots. Okay. All right. So next. Okay, next, I'm gonna clear this. Oops. Okay, so now here's a trial question here. So we've got an expansion here, and then we're going to find value of coefficient. So how on earth do we do that? So we need to recall the general term part, which is what I was mentioning earlier, right? Whatever the term number, it matches with the R. And notice that here in the coefficient, it was 1 out of x over 7, 1 out of x power 7. So first thing we take note, 1 out of x power 7, right? It actually equals to x power negative 7, equals to x power negative 7, okay? So today, we're looking at a term that will give us a final of x power 7. All right, so we're looking at a power that gives us x power 7. We're looking for the term that gives us x power 7. So how do we do that? We're going to match the coefficient. So we're going to say that we don't know what the R term is. So we're going to say that let TR equal to, so because the power in this expression was 13, we go 13. We don't know R, we put in R here, right? a, the first term on the left, right, goes to the power here, and the power decreases. Remember, we said it should decrease by r, right? And b, which we say is equal to 1 over x, was actually equal to x power minus 1. So x power minus 1, we put a power r over here. So this is what we do to find this term, to express this term in a way that makes sense. And after that, we're going to now compare the powers of x, because we don't know what r is, but we do know that the final result of this term should give a power of -7, right? So here we're going to just extract the powers of x. We're going to extract the powers of x. So what happened to the powers of x here? We're going to take a look at the power of x here. Okay, so here we notice that x in the left, in the first term, gives me a power of 13 minus r. And then the b will give us x of x power -1 times r. So we're going to do a comparison based on this. And it gives us something like this. So we're comparing that the powers of x here due to a was 13 minus r. Power of x due to b was -1 times r. The result of that should give me x power -7. So based on this, we can solve for r, right? So we solve it carefully. We can find that r should equal to 10. That's good news, because now that we know r is 10, then we are saying that we're referring to the 11th term. Right? So we're now clear that we're looking for the 11th term of this expansion. So what we can do is to now put in r equal to 10 into this expression. So to find the coefficient of x power 7, coefficient of t11, right, goes 13, right here, r is 10, yeah, r is 10. Yeah, r is 10 because r was 10, right? And then based on coefficient, we don't need the x powers anymore, because all the question wanted was the coefficient. All the question wanted was the coefficient. So we just focus in on the coefficient, and that would be it. So always remember, coefficient means that we don't need the x anymore. So we key in carefully these three things. It should go to, right, 13 choose 10, give me 286, 3 power 3, all right, should give me 27, 1 power 10. Thankfully, it was 1, because the coefficient in this case, there was no number in front of, there was no real number. The number in front of the x power 1, x power -1 was 1, so it just goes to 1 power 10, right? And from there, they should give us 7,722. Okay, yeah. Next. Okay, we're going to clear this again. All right. Now, there's other version of binomial expansion. We can also deal with finding things like the n power. So this is where it gets a little bit more freaked out, right? To find the n power, right? So here's a question here. We go try to expand. So here they gave us the 3 terms in this expansion. So this is our clue. When we do our expansion of binomial, we're going to, since they gave us 3 terms, so we're going to expand our binomial in 3 terms, right? We're going to expand our binomial to 3 terms. So we're going to use our binomial expansion general formula as such, right? So this was our expansion. We simplified it to x power 1 plus x over p, whole thing power n. We don't know n, but that's fine. For now, we just key in what we used to before. So n, choose 0. Again, first number was n, right? Take n minus 0. Second number was x out of p, power that start from 0. And then it's our first term. Second term, n, choose 1. Okay, n power, and so 1, again, goes reduce the power by 1. To b term, x over p, right, power 1. So n choose 2, and then we continue until we go to the x to the x squared term where the power was 2. Okay? So we do it carefully here, and then we simplify. So here, good news, we are comparing again. N choose 0 gives me 1, because any number choose 0 is 1. Power any 1 to the any power is still 1. And good news again, x power p power 0, anything power 0 is still 1. So first term is definitely going to be 1. Okay, n choose 1 is just going to be n. Okay, 1 again, anything power 1. will be 1 to any power is still 1, right? And then x over p is still 2. Now, trickiest one is from n choose 2. So n choose 2, where do we get it from? So remember what we did earlier. We always say that our numerator starts from the higher power. Numerator starts from higher power. So in this case, we don't know what the power was, but we call it n. And then what do? Every next number, it decreases by 1. So this is why we go for numerator n multiplied by n minus 1, right? And for denominator, I just put 2 there, but 2 came from what? Our first number was always divide by starting from 1 and then increasing onward. So because this is n choose 2, our denominator was in fact 1 times 2, right? Denominator would look like 1 times 2, right? I'll just multiply this for you to see clearly. So this would be our denominator here, right? All right, okay, right? And then simplify 1 power anything, still 1. And then this part, expanding carefully, I left it there. I haven't expanded it, right? Because you can see that in the next line. Next line should go like this, right? Next line should go like this, right? So 1 power 2 is just here. Just draw an arrow here. This was where we got the 2 from, okay? Now, so simplify that. You get 1 over, so I simplified the coefficient of the n and p. I brought the n and p together. P is in denominator, so n over p, and then that will be the coefficient for the x term. And then here, what we did here very, very carefully, when we square x out of p, so x becomes x squared over p squared, right? So p has gone to the denominator here together with the 2, right? Numerator stays the same, and bracket n minus 1. Okay, now from here, we're going to compare with what they've given us. What they've given us was 1 matching with 1. So that's fine. NRP will match with something here in x. NRP measures coefficient was 1 here. So that's how we can infer that NRP is equal to 1. So that's how we can say that based on that, n would equal to p, right? And then now comes the trickier one. For coefficient of x squared itself, we take what we did here, which is n bracket n minus 1 out of p to p squared. This we match to 9 out of 20, right? This we match to 9 out of 20. Now, what we do here is substitute n equal p, right? So we simplify this. What we did here, we did a cross multiply. 20 goes over to the left-hand side, and 2p squared goes over to the right-hand side. They'll multiply each other. Then we expand this very carefully. We're showing a peeking here. Then we simplify this carefully as well. So we end up with 2n squared minus 20n equals 0. Factorize that very carefully. Should give me 2n equals 0, which is n equals 0, and then n equal to 10. So because we're dealing with binomial, right? N definitely cannot be 0 for this to make sense, because anything power 0 goes back to 1. So that's why we reject n equals 0. So based on this, we found that p equals to 10. So thankfully, this was all they did for the question, because all they wanted was to find the value of n and of p, right? So that's how we end this stage, right? But of course, bearing in mind when it comes to the actual exam question, once we found the p, they probably say, okay, hence find the term and hence find whatever other thing that they want to do, right? So this can and usually does happen for actual questions, okay? Now, so we're going to try some of these other questions. So you can try these questions, and if you're confused, you can just ask me as well, right? So first question is interesting. First one, they ask us to write the first 3 terms. So take note, we're looking at 3 terms in this expansion. So this, we go back to our general formula. We go back to our general formula and expand it carefully, taking 2 as a and taking ax this time as b, right? And then given that the next part is more interesting, next part is that we're combining what we have expanded to another term, right? To another term here. So this term has 2 terms itself, a constant term which doesn't have an x, and a term which has an x. So this part, it gets a bit tricky, but if we expand this really, really carefully, then the next stage of the skill is that we're able to compare some of the terms. Here's my clue. My clue is this. You probably should be able to find b first. you should be able to find B first. Yeah, you should be able to find B first. And that would be quite separate. And yeah, so based on that, I think you should be able to solve this. Again, if you're confused, let me know. Okay. Right. Another question that you can handle is next one here. Okay, here there's another term called independent of x. What do we mean by term independent of x? Term independent of x means that my x power should actually, term independent of x refers to a situation where x, the power of x actually goes to 0. So we've seen earlier how we can match the power, how we can match the powers of the a and the b, combine that, and how we can get a result of 0, right? So here we're recalling our n choose r method, where n today n was 15. R, we don't know r, but even if we don't know r, we can still find the value of r because they've given us this clue: x independent, in term independent x means that x power has to equal to 0. Okay, so let me know if you're confused with this, and we'll definitely connect again. Yeah. All right. There we go. Okay, so that's what we have now. Thank you.